In this video, we are going to see dual simplex method. See, dual simplex method means it is a specialized form of simplex method in which the optimality is maintained in all the iterations. Say, for minimization problem, the optimality condition is all the Cj minus Zj must be greater than or equal to 0, which means we have to get 0 or positive value. So if we get 0 or positive value, then the problem is optimal. Okay. If we get any negative value, so while we calculate Cj minus Zj, if we get any negative value, then the dual simplex method is not applicable. So in the dual simplex method, we'll be getting positive value only. So it is called as optimal. Okay. The second step is we need to find the feasibility. See, initially the solution may not be feasible. Okay, in the simplex table, in the solution column, okay, we have to get the positive value. For minimization problem, okay, the feasibility condition is the solution must be greater than or equal to 0, which means we have to get the positive value. Okay, then the problem will be optimal as well as feasible. Okay, but initially in the first simplex table, we may not be getting all positive value. See, initially the solution may not be feasible, which means we won't be getting all positive value in the solution column. So the successive iterations will remove the infeasibility. So we have to move further in order to remove the infeasibility. If the problem is feasible in an iteration, then the procedure will be stopped because the solution obtained is feasible and optimal at that condition. Let me explain in a simple way. For the minimization problem, the optimality condition is all the Cj minus Zj must be greater than or equal to 0. This optimality should be maintained in all the iterations. If we get any negative value, then the dual simplex is not applicable. Okay. The next point is for the minimization problem, the solution must be greater than or equal to 0. Initially, the solution may not be feasible. That is, in the solution column, we may get some negative value. So, we should do further steps to remove infeasibility. Let us see one illustration problem to get more clarity. Look at this problem. Solve the following LPP using dual simplex method. So, look at this problem. It's a minimization problem. Minimization Z is equal to x1 plus 2x2 plus 3x3. Okay, this is the objective function subject to the constraints. So, three constraints are there. First constraint is 2x1 minus x2 plus x3 greater than or equal to 4. Second equation, x1 plus x2 plus 2x3 less than or equal to 8. Third constraint, x2 minus x3 greater than or equal to 2. x1, x2 and x3 greater than or equal to 0. For minimization problem, we need to have only less than or equal to type. But here we have greater than or equal to in the two constraints. The first constraint and third constraint. The first step is just convert the greater than or equal to into less than or equal to wherever it is required. So in this problem, we have to convert the first constraint as well as third constraints, because in the first constraints we have greater than or equal to, in the third constraints also greater than or equal to. So we need to convert greater than or equal to into less than or equal to by multiplying with minus 1. This is the first step. The second step is we need to add slack variable. Here we have three constraints. So we need to add S1, S2 and S3. First write the objective function. Minimization Z is equal to x1 plus 2x2 plus 3x3 subject to the constraint. Look at the first and third constraints. These constraints are greater than or equal to type. So we need to convert into lesser than or equal to type by multiplying with minus 1. So the first one is 2x1 will be minus 2x1. Minus x2 will be plus x2. Plus x3 will be minus x3. And plus 4 will be minus 4. Less than or equal to minus 4. Look at the second constraint. The second constraint is lesser than or equal to type. So we need not change anything. Simply you can write the same value. Third constraint, minus x2 plus x3 lesser than or equal to minus 2. So x1, x2 and x3 greater than or equal to 0. So we have converted greater than or equal to into lesser than or equal to type. The second step is now we have to add slack variables. Plus s1 is equal to minus 4. Second equation, x1 plus x2 plus 2x3 plus slack variable 2 is equal to 8. Third one, minus x2 plus x3 plus slack variable 3 minus 2. So x1, x2, x3, S1, S2 and S3 greater than or equal to 0. Write the slack variable value along with the objective function and assign the value as 0. So plus 0 S1 plus 0 S2 plus 0 S3. See the simplex table format, basic variables. Look at the problem. x1, x2, x3, s1, s2 and s3 are basic variables. So x1, x2, x3, s1, s2 and s3. Cj values are objective function values. Look at the objective function. Minimization z is equal to x1. x1 value is 1, 2x2. x2 value is 2, 3x3. x3 value is 3. For slack variables, S1 0, S2 0, S3 also 0. So 0, 0, 0. Here 3 slack variables are there. No, S1, S2, S3. The values of slack variables are 0, 0, 0. This is the format of initial simplex table. Now we have to write the values of 3 constraints. Look at the first constraint, minus 2x1. So x1 value is minus 2. Minus 2. Here x2 is plus x2, that is plus 1, minus x3. Minus x3 means minus 1 and s1. So 1. In the first iteration there is no s2, s3. So put 0 and 0. Okay, solution is minus 4. Look at the second constraint, x1. So plus 1, x2 plus 1, 2x3. So x3 is plus 2 and s2, slack variable 2 is there. No. So for s2, 1. For s1 and s3, 0. Solution is 8 plus 8. In the same way, third constraint. There is no x1. So put 0. So x2 minus x2. No. So minus 1 plus x3. No. Plus 1. S3 is there. So S1, S2s are 0. S1 0, S2 0, S3 is there. So put 1. And solution is minus 2. Now we have constructed the simplex table. Now we need to find out Zj values. In order to find out the Zj value, this is the procedure. 0 into minus 2 plus 0 into 1 plus 0 into 0. So 0 into minus 2 plus 0 into plus 1 plus 0 into 0 is equal to 0 into minus 2, 0 plus 0 into 1, 0 plus 0 into 0, 0. So you'll be getting 0. So the first value is 0. In the same way, for the second value, 0 into 1, 0 plus 0 into 1 0 plus 0 into minus 1 0. Third value 0 into minus 1 0 plus 0 into 2 0 plus 0 into 1 0. See, in the same way we have to find the value for S1, S2 and S3. The next step is we need to find Cj minus Zj value. Cj minus Zj. So look at the Cj values. Cj is 1. 1 minus Zj value is 0. So 1 minus 0 is equal to plus 1. 2 minus 0 is equal to 2. Then 3 minus 0 is equal to 3. 0 minus 0 is equal to 0. 0 minus 0 is equal to 0. 0 minus 0 is equal to 0. See, look at the Cj minus Zj values. All the values are positive values. So here, for the minimization problem, the Cj minus Zj value must be 0 or greater than 0. That is, we need to have positive value only. Then the problem is optimal. If we get any negative value in the Cj minus Zj, then we cannot apply dual simplex method. So in this problem, we have got positive values. So this problem is optimal. The second step is we need to see whether the problem is feasible or not. So for that, see the solution column. In the solution column, we have got two negative values. For the minimization problem, the feasible condition is we need to get positive value. In the solution column, we need to get positive value. But we have got two negative values. So the problem is not feasible. Optimal but not feasible. So we need to remove the infeasibility. So in order to remove infeasibility, we need to go further. For that, we need to find the entering variable and leaving variable. For leaving variable, find out the most negative value in the solution column. Here we have two values, minus 4 and minus 2. So which one is most negative? Minus 4 is the most negative value. So this will be the leaving variable. So S1 is the leaving variable. Okay, according to this condition, we can able to identify the leaving variable. So S1 is the leaving variable. Now we need to find the entering variable. For entering variable, we need to follow one simple procedure in order to find out the entering variable. Let us see the determination of entering variable. This is the format. Okay, determination of entering variable. What are the variables are here? X1, X2, X3, S1, S2 and S3. These are the variables. First step, take the Cj minus Zj values and change the sign. Cj minus Zj, no, minus Cj minus Zj. And here we have got positive value, no, take minus 1. For X2, minus 2. For X3, minus 3. All zeros you can write 0 for S2, 0 for S3 also 0. Now write the leaving variable. So which one is leaving variable? S1 is a leaving variable. No, just take the value as it is. For X1 minus 2, X2 1, X3 minus 1, S1 1, S2 0, S3 0. S1 minus 2 plus 1 minus 1 plus 1 0 0. Just take the value as it is. Minus 2 1 minus 1 1 0 and 0. Now find the ratio between Cj minus Zj and S1 values. Okay, while you take the ratio, just ignore positive values and 0 values in the denominator. For example, in the first value, minus 1 divided by minus 2. So you can find the ratio. So minus 1 divided by minus 2 is equal to plus 1 by 2. For X2 value, minus 2 divided by plus 1. Okay, here the denominator is a positive value. Just ignore it. You need not put any ratio for this. The third one is minus 3 divided by minus 1. The value is 3. Okay, and look at the next one. 0 divided by 1. The denominator value is positive value. Just ignore it. Here 0 divided by 0. 0 also ignore. Here also 0 divided by 0, so ignore. Okay, so while we calculate the ratio, if we get any positive value in the denominator or if we get any 0 value in the denominator, just leave it. You need not find any ratio for that. Okay, now we have got the ratio for x1 and x3. After finding the ratios, now we need to find the least value. So which one is smallest value? 1 by 2 or 3? 1 by 2 is the smallest value. So this will be the entering variable. So x1 is the entering variable. Okay, we have got leaving variable as well as entering variable. Now we have to move further to remove the infeasibility in the solution column. See, S1 is the leaving variable. Just put one circle to identify the leaving variable. Look at the determination of entering variable table. Here we have got x1 as a entering variable. No. So x1 is the entering variable. x1 is the entering variable. No. Just highlight this column. See, this one is a pivotal column and this one is pivotal row and this one is pivotal element. That is key row, key column and key element. So with this we need to proceed the second iteration. In the second iteration, just take the basic variables x1, x2, x3, s1, s2 and s3 and cj values as it is 1, 2, 3, 0, 0 and 0. Look at the first iteration. S1 is the leaving variable. So here we have to write the entering variable. Which one is entering variable? X1 is the entering variable. Here you have to write x1. Okay, value for x1 is 1. Here instead of 0 you have to write 1. To find the new value for the entering variable, just take the each and every element and divide with the key element. That is minus 2 divided by minus 2, 1 divided by minus 2, minus 1 divided by minus 2, 1 divided by minus 2, 0 divided by minus 2, 0 divided by minus 2 and minus 4 divided by minus 2. In order to find out the new value, we have to follow this procedure. Minus 2 divided by minus 2 plus 1. 1 divided by minus 2 minus 1 by 2. Minus 1 divided by minus 2, 1 by 2. 1 divided by minus 2 minus 1 by 2. 0 divided by minus 2, 0. 0 divided by minus 2, 0. Minus 4 divided by minus 2 is equal to plus 2. Okay, this is the procedure to find out the new value for entering variable. Look at the first iteration. To find out the new value for S2 and S3 values, we have to use one formula to find out the new values. Let us see the procedure to find out the new values. For S2 and S3, the values are 0 and 0. So write the values as it is. S2 and S3, 0 and 0. We are going to apply one formula for that. This one is row 1, this one is row 2 and this one is row 3. In the second iteration, the new value is, first one is the entering variable. No, this one is row 4. Now we need to find value for row 5 and row 6. Now we need to find the new value for row 5. For that, old value minus key column value into row 4 value, that is new value in the second iteration. For S2, the first value is old value is 1 minus key column value also same 1 into new value, that is row 4 value is 1. Old value is 1 minus key column value also 1 into row 4 value is 1, that is new value is 1. Answer is 0. For x1, new value is 0. In the same way, we need to find the value for x2, x3, s1, s2, s3 and solution. For x2, the old value is 1 minus corresponding column value is 1 into new value is minus 1 by 2. old value 1 minus corresponding column value also 1 into new value is minus 1 by 2. The answer is 3 by 2. 3 by 2. For the next one, old value is 2 minus key column value is 1 into new value is 1 by 2. The answer is 3 by 2. Old value is 0 minus corresponding column value is 1 into new value is minus 1 by 2. The answer is 1 by 2. Next one, old value 1 minus corresponding column value is 1 into new value is 0. The answer is 1. For the next one, old value 0 minus key column value is 1 into new value is 0. The answer is 0. For solution, the old value is 8 minus key column value is 1 into new value is 2. The answer is 6. For S3, that is row 6, we need to follow the same formula. That is, for the first value is old value is 0 minus corresponding key column value also 0 into new value is 1. The answer is 0. For the next value, the old value is minus 1 minus corresponding column value is 0 into new value is minus 1 by 2. Answer is minus 1. The next value, old value is 1 minus corresponding key column value is 0 into new value is 1 by 2. The answer is 1. See the next one. The old value is 0 minus key column value is 0 into new value is minus 1 by 2. The answer is 0. For the next one, old value 0 minus corresponding column value also 0 into new value 0. The answer is 0. The next one is the old value is 1 minus corresponding key column value is 0 into new value is 0. The answer is plus 1. For solution, the old value is minus 2 minus corresponding column value is 0 into new value is 2. The answer is minus 2. Now we need to find Zj. For Zj, take the first value, this into this plus this into this plus this into this. Okay, so 1 into 1 plus 0 into 0 plus 0 into 0 is equal to 1. In the same way, for the second value, 1 into minus 1 by 2 plus 0 into 3 by 2 plus 0 into minus 1. Minus 1 by 2. In the same way, we need to find Zj for all other values also. 1 into 1 by 2 plus 0 into 3 by 2 plus 0 into 1 is equal to 1 by 2. For the next value, 1 into minus 1 by 2 plus 0 into 1 by 2 plus 0 into 0. The answer is minus 1 by 2. For the next value, 1 into 0, 0 plus 0 into 1, 0 plus 0 into 0, 0. So the answer is 0. Next value, 1 into 0, 0 plus 0 into 0, 0 plus 0 into 1, 0. So the answer is 0. Okay, after finding Zj value, next we have to find Cj minus Zj values. Cj minus Zj. Cj is there, no? See the objective function. Cj values are 1, 2, 3, 0, 0, 0. Z values are 1, minus 1 by 2, 1 by 2, minus 1 by 2, 0 and 0. So now we have to find Cj minus Zj. Cj first value 1 minus 1 is equal to 0. Then 2 minus, already minus is there, no? So plus 2 plus 1 by 2 is equal to 5 by 2. In the same way, we need to find Cj minus Zj values for all other values. 3 minus 1 by 2 is equal to 5 by 2. See the next value, 0 minus minus 1 by 2. So it will be plus 1 by 2. Next value, 0 minus 0 is equal to 0. Then the last value, 0 minus 0 is equal to 0. Okay, after finding Cj minus Zj value, now see the optimality condition. So our optimality condition is all the Cj minus Zj must be greater than or equal to 0. So here we have got all zeros and positive value. So optimality is maintained in this iteration also. Now we have to see the solution column to check the feasibility. Look at the solution column. Still we have got one negative value. So the feasibility condition is all the solution value must be positive. But we have got one negative value, which means this solution is an infeasible one. So we have to move further in order to remove the infeasibility. So now we have to find the leaving variable and entering variable. In order to find out the leaving variable, see the solution column, we have to select the most negative value. But here we have got only one negative value. So this will be the leaving variable. That is S3 is the leaving variable. Now we need to find the entering variable. Variables x1, x2, x3, s1, s2 and s3. Okay, first take the Cj minus Zj value and change the sign. Minus Cj minus Zj. x1 value is 0. x2 value 5 by 2. No, so minus 5 by 2. x3 value 5 by 2. So minus 5 by 2. S1 value is 1 by 2. So minus 1 by 2. S2 value 0. S3 value also 0. Now take the leaving variable values. So leaving variable is S3. Take the S3 values. X1 0. X2 is minus 1. X3 is plus 1. S1 is 0. S2 is 0 and S3 is 1. Okay, and after entering these two values, now we need to find ratio. While we find the ratio, okay, we have to see two things. Just ignore any zero value in the denominator or any positive value in the denominator. These are the two things you must see. First one, 0 divided by 0. No need to find any ratio for this because we have got 0 in the denominator. And second one, minus 5 by 2 divided by minus 1 is equal to plus 5 by 2. For x3, here we have got positive value in the denominator. So we need not find any ratio. Next one, minus 1 by 2 divided by 0. Again we have got 0. Just ignore. Here 0 divided by 0. Again denominator value is 0. Just ignore. And the last one, 0 divided by plus 1. So here also we have got a positive value in the denominator. So we need not find any ratio for this. Here we have got only one value. So this will be the entering variable. If we get two value means then we have to find the least one. Least positive will be the entering variable. But here we have got only one positive value. So x2 will be the entering variable. See the second iteration. Now we have found x2 as entering variable. This one is pivotal row and this one is pivotal column and this one is pivotal element. That is, this one is key row and this one is key column and this one is key element. Okay, now we have to move further in order to remove the infeasibility. For that we have to form third iteration. Now we need to form the third iteration. In the third iteration, so which one is entering variable? Look at the second iteration. S3 is the leaving variable and x2 is the entering variable. So we have to write x2 instead of S3. So this one is row 7. In the row 7, the entering variable is x2. So x2 value is 2. So in the CBI column, write 2. So 2 is the cost for x2. Okay, now we have to fill the new value. So for new value, just divide the pivotal element with all other elements. So pivotal element is -1. So the new value will be 0 divided by -1, -1 divided by -1, 1 divided by -1, 0 divided by -1, 0 divided by -1, 1 divided by -1 and -2 divided by -1. Then you will be getting new value for row 7. 0 divided by -1, 0. -1 divided by -1 plus 1. 1 divided by -1 minus 1. 0 divided by -1 is equal to 0. 0 divided by -1, 0. 1 divided by -1, minus 1. Minus 2 divided by -1 is equal to plus 2. So now we have got the value for entering variable. Okay, row 7 is there. Now we have to find row 8 and row 9. For that we have to follow one small formula. Look at the previous iteration. x1 value is 1. x1 value is 1. Second one is s2 value is 0. s2 value is 0. Okay. Now we need to find the new value for this row as well as this row. Okay, for that you have to follow one small formula. Look at the formula. New value for row 8 is equal to old value minus key column value into row 7. That is new row value. For row 8, the old value is, look at the previous iteration. Old value is 1 minus key column value is -1 by 2 into new value is 0. I'll show the calculation. For x1 is equal to old value is 1 minus key column value is -1 by 2 into new value is 0 is equal to plus 1. For x2, the old value is -1 by 2 minus key column value again the same value -1 by 2 into new value is 1. For x2, old value is -1 by 2 minus key column value is -1 by 2 into new value is 1. The answer is 0. For the next value, old value is 1 by 2 minus key column value is -1 by 2 into new value is -1. The answer is 0. For the next value, old value is -1 by 2 minus key column value is -1 by 2 into new value is 0. The answer is -1 by 2. For s2 value, the old value is 0 minus key column value is -1 by 2 into new value is 0. The answer is 0. Next one, the old value is 0 minus key column value is -1 by 2 into new value is -1. The answer is -1 by 2. For solution, the old value is 2 minus key column value -1 by 2 into new value 2. The answer is 3. In the same way, we need to find the new value for row 9 also. Okay. See the old value. The old value is 0 minus key column value 3 by 2 into new value 0. So the answer is 0. For the next value, old value is 3 by 2 minus key column value, same value 3 by 2 into new value is 1. The answer is 0. The next one, the old value is 3 by 2 minus key column value 3 by 2 into new value -1. The answer is 3. Next one, the old value 1 by 2 minus key column value 3 by 2 into new value 0. Answer is 1 by 2. Next one, old value is 1 minus key column value is 3 by 2 into new value is 0. The answer is 1. Next one, old value 0 minus key column value 3 by 2 into new value -1. The answer is 3 by 2. The next one, the old value is 6 minus key column value is 3 by 2 into new value is 2. The answer is 3. Now we need to find Zj values. For Zj value, see the first one, 2 into 0, 0 plus 1 into 1, 1 plus 0 into 0, 0. So the answer is 1. For x2, 2 into 1, 2 plus 1 into 0, 0 plus 0 into 0, 0. So the answer is 2. Next one, 2 into minus 1, minus 2 plus 1 into 0, 0 plus 0 into 3, 0. So the answer is minus 2. For S1, 2 into 0, 0 plus 1 into minus 1 by 2, minus 1 by 2 plus 0 into 1 by 2, 0. So the answer is minus 1 by 2. For S2, 2 into 0, 0 plus 1 into 0, 0 plus 0 into 1, 0. So the answer is 0. For S3, 2 into minus 1, minus 2 plus 1 into minus 1 by 2, minus 1 by 2 plus 0 into 3 by 2, 0. So the answer is minus 5 by 2. For solution, 2 into 2, 4 plus 1 into 3, 3 plus 0 into 3, 0. So the answer is 7. Now we need to find Cj minus Zj values. For x1, 1 minus 1 is equal to 0. For x2, 2 minus 2 is equal to 0. For x3, 3 minus 2 is equal to plus 5. For s1, 0 minus 1 by 2 is equal to plus 1 by 2. For s2, 0 minus 0 is equal to 0. For s3, 0 minus 5 by 2 is equal to plus 5 by 2. Okay, see, look at the Cj minus Zj value. In the third iteration also, the optimality is maintained. We have got all positive values. Now look at the solution column for feasibility. See, in the solution column also, we have got all positive values. So we have to stop the procedure because here we have reached the optimality as well as feasibility. So this solution will be the optimal and feasible solution. Now write the x1, x2 and x3 value. x1 value is, see the solution column, 3. x2 value is 2. So x3 value is not there, so write 0. x1 is equal to 3. x2 value is 2 and x3 value is not there, so put 0. Optimal z value is, look at the solution total, 7. So 7. Now you can check the answer by applying this value in the objective function. See the objective function. The objective function is minimization z is equal to x1 plus 2x2 plus 3x3. So x1 value is 3 no. So put 3 plus 2 into x2 value is 2 plus 3 into x3 value is 0. So 3 plus 2 into 2, 4 plus 3 into 0, 0. So the answer is 7. So we have got the optimal value, that is the minimization z is equal to x1 plus 2x2 plus 3x3 is equal to 7. This is the optimal and feasible solution. This is the way to solve LPP using dual simplex method. Hope you all understand this concept. Thank you.